Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why sometimes things just don't add up in psychology studies? Well, buckle up, because today we're talking about how we measure psychological stuff, and why it might be trickier than we think. Imagine trying to measure happiness. For ages, scientists have relied on something called operational definitions. It's like saying if someone smiles a lot and fills out this happiness questionnaire with high scores, then they are happy. It's based on what we can directly see or measure. Think of it like defining a kilogram by a specific metal weight. It worked okay for a long time, helping psychology move away from just thinking and toward doing experiments. This approach gave us a more rigorous way to study things. But here's the twist. The way we usually do it in psychology, where one specific test or question defines a whole concept, is actually causing problems. The researchers in this paper, Kvam and Abhay Alaukik, argue that this simple way of defining things, which they call simple operationalism, is actually hiding a lot of what is going on. They say it is like boiling down a really complex idea, like intelligence, to just one number from a single test, ignoring all the other things that make up intelligence, and all the other things that might be going on when someone takes that test. This simple approach has led to a bunch of issues. One big one is surrogation, where the measure itself starts to feel like the concept. So instead of the test pointing to intelligence, the test becomes intelligence. This can lead to a clutter of different tests for the same thing, making it hard to build consistent theories. It is also a big contributor to what people are calling the replication crisis in psychology. You know, when studies can't be repeated by other scientists. If we're defining things too narrowly, our findings might not hold up elsewhere. The authors suggest a better way, relational definitions. Instead of defining a concept by just one measurement, they propose using complex mathematical models to understand how a concept shows up across many different measurements and tasks. Think of it like this: instead of defining strength by just how much someone can lift once, a relational definition would look at how they perform in weightlifting, sprinting, endurance tests, and how all those different performances relate to underlying factors like muscle power and cardiovascular health. These models can account for where the real variability and error are. So, how does this work in practice? Let's look at their example. They simulated data for two memory tasks. One where people decide if they saw something before recognition memory, and another where they have to remember where something was location memory. Traditionally, for recognition memory, they might just look at how many questions people got right. For location memory, they'd look at how far off people were from the correct spot. When they used simple operational definitions, just correlating the accuracy on the first task with the error on the second, they found a connection, but it was a bit weak. They might have concluded that these are pretty different kinds of memory, but when they used their new relational definition approach, which involved building sophisticated models that looked at all the details of performance on both tasks, not just accuracy or error, but also how quickly people responded. For example, they found a much stronger and clearer relationship between the underlying memory strength in both tasks. This is because the relational models can capture other important latent variables, like how cautious someone is when making a decision. Simple operational definitions completely miss this. By using these richer models, they could disentangle the true memory strength from other factors, leading to a much more accurate picture of what is going on. It's like going from a blurry photograph to a high. Definition 1. This approach is super important because it helps solve the problem of having tons of different measures that all claim to measure the same thing, but don't always agree. Relational definitions provide a formal way to check if different tasks are actually tapping into the same underlying psychological construct. It helps us move toward a more unified understanding of concepts like impulsivity or memory. So, what does this mean for us? It means that the way we measure psychological concepts might be about to get a whole lot more sophisticated. Instead of relying on one single test or questionnaire, we're going to see more and more use of complex models that look at how behavior plays out across many situations. This should lead to more reliable and valid findings in psychology, helping us understand ourselves and others better. It also means that the math in psychology is going to become even more important, which is pretty cool. Now, is this perfect? No study is. This is a more complex way of doing research, and it requires more advanced modeling skills. It also means we might have to question some of the findings that relied on simpler operational definitions in the past. But the payoff for doing it right is a much deeper and more trustworthy understanding of the human mind, because this whole idea of relational definitions is still pretty new and complex. It is going to take time for it to be widely adopted, but the authors are optimistic. They believe that by embracing these richer, model-based approaches, psychology can become a more rigorous and cumulative science. solving big problems like the replication crisis and giving us more reliable insights into what makes us tick. What do you guys think about this shift away from simple operational definitions? Are you excited about more complex models in psychology? Let me know in the comments below. And if you found this breakdown helpful, please hit that like button. Subscribe to Rubin's Mind Lab for more science explained and ring that notification bell so you don't miss our next deep dive. Thanks for watching, and I'll see you in the next one.